Good morning. I'm Mike Hostetler, COO of Versatus.
What's up, dudes? I'm Andrew Hathaway. They call me the chief guinea pig, so
Yeah.
I'm like, bull in a china shop.
That's right. So what is Versatus? We're building what we call the universal DApp engine. So the vision is to create a compute layer on top of blockchain that allows developers from the Web 2 world to bring any language to writing programs, or what smart contracts we call programs, to the Web 3 world. There's 22,000 developers in Web 2, and we believe that reaching the 27 million developers in Web 3 is how we bring more devs to this world. Then that will bring more dApps and then ultimately more users. So our first product is a language agnostic stateless rollup built on to settle transactions back to EigenDA. This allows those Web 2 developers to build smart contracts in the language they already know and love. And we're going to be looking at some of that today. Languages like Python, TypeScript, C++, Go, and maybe even COBOL someday. So part of the design of our stateless rollup is to equip those developers with a really simple framework for how they can settle data back to the blockchain. In the Web 2 world, a lot of Web 2 developers were trained on the CRUD acronym. Create, read, update, and delete. And so we've built our chain to have a very similar, very familiar framework where they can create tokens, update those tokens, transfer tokens between two accounts, and ultimately burn those tokens. The read, because it's a public blockchain, happens outside of this framework, but the read is there as well. Part of that design is a focus on developer experience. Developers are our customers, and we've gone to great lengths to make it accessible to them and make it easy for them to build programs and smart contracts. And one of those design elements is that JSON is what is used to send data into those contracts, and then those contracts spit JSON out. We could have done this many different ways, but we did that to make it easy for those developers to understand what was going on. Again, just lower that barrier of entry for how they both write, design, debug, and ultimately build dApps on top of these smart contracts. We really adhere to this Unix philosophy of using text versus binary data formats for inputs and outputs in those contracts. So we're going to go through a demo right now and build a token together.
It's really fun. So this right here is Versatus JavaScript. It is a TypeScript library, and it also comes with a command line interface that we built. It helps developers easily build and test and deploy smart contracts. So what we're going to do right now is create a program that, sorry, I keep, not smart contracts, they're programs. We're going to create a program that will pretty much change the metadata within that program through the command line as we broadcast the transaction to the network. So right now, for each program that we build, you get compute inputs, and compute inputs have a transaction along with account data. Account data can be thought of as like the program state, So if you want to like we were building something the other day, we put Snake, like a small JavaScript version of Snake, into the token, which is pretty cool. And so you can literally put anything in there. Right now we don't have any limits on that. Eventually we might have limits on that, but I think we probably will, because it's put a gigabyte into a token and then it's ripping around the network. It'd probably be a little bit cantankerous to work with. But okay, so we have our compute inputs coming in. We parse out the transaction inputs. So the transaction inputs is a string. So we parse that string into a JSON object. And right here, we're going to pass in, through JSON, a name field. So when we pass the name in, Mike is going to update the token metadata with the name that is passed in along with the current time. Oh yeah. So as you can see here, we're building all sorts of tools that help alleviate some of the pain points associated with actually building a program. And obviously this is very actively in development, but we're at a point now where you can take this and interact with the laser network. Laser network it settles to EigenDA, and we're plugged into we use Kaleido, which is like a software as a service, like blockchain as a service, pretty much. But we're planning on supporting pretty much any popular blockchain. Including like Magma, which is, we just deployed the executable Oracle over there, Solana. We're talking about Bitcoin, which is super fun. And so we have a build update instruction, which will spit out an array of JSON instructions that the protocol then knows how to act on. So let's deploy it. So we're going to use the VSJS command line interface, which I think we're going to switch to laser control. It's got more of a badass name.
You want to talk about what's going on here?
Yeah, cool. So we pass in the author, M. Hostetler, the name of the program that we're deploying. This gets deployed to an IPFS instance that's in the network. Program name is CertiK. The symbol is CertiK. We're initializing it. The supply is 1. The total supply is 1. Every program inside of here is a token. So that's a good way to think about it. And then the recipient address, it's like gonna send it to, this is Mike's address right here. There it is. And so we have a program address back. It gives you some information about the recipient address and obviously everything else that you passed in at the command line. So now we're gonna take that and call the program. So he had just written the hello method in that program, which will literally take that name out. It'll parse that string into JSON, take that field that he's going to put in there, and then put it in the metadata and update that metadata along with the timestamp, as you saw in the method. Wendy. Cool, so there's our output. This is what sits back. It's the state of, I think, this account that is actually making that call. Cool, and so now what we're doing is we're gonna go get that account and show you what the state of this program account is. So every program has an account, and the account is effectively the state. Look, Wendy, here you are.
Welcome to the blockchain.
Along with the time, oh, my watch died. But yeah, so that is it.
That's it.
Yeah.